Hello everyone. I'm going to explain one more important concept of differentiability, part 3. This is the last class of differentiability. I would like to explain what are the algebraic properties of differentiable functions and how to find out non-differentiable points of minimum and maximum of two or more functions. This concept is very important. And even though I have explained that solving of functional equations in separate videos, but still I'll solve a few questions of functional equations using the differentiability method. So algebra for differentiable functions is so simple. Here, if f and g are differentiable functions, then their sum, difference, product, quotient, and composite are all differentiable functions. So this is the first point. So sum and difference and product and quotient and composite of two differentiable functions is differentiable function. The most important second point is that sum, difference of differentiable function, non-differentiable function is non-differentiable function. Sum of one differentiable function and one non-differentiable function is a non-differentiable function. Well, okay. Not product, remember, not product, only sum. And converse of the first statement is not true. Converse of the first statement is not true. So what is that converse of first statement? If f plus g, f minus g, fg are differentiable at c, then individual functions f comma z may or may not be differentiable at c. This is very important concept. So if some product difference are differentiable, then individual functions may or may not be differentiable. For example, you see, here is f of x, a function is given. This is the function. We would like to test the differentiability of this function. All right. See, this is a differentiable function. This is a differentiable function. All right. And this is non-differentiable at 0. Non-differentiable at 0. At x equal to 0. All right. Okay. So what is f of x function? What is f of x function? F of x, I can write that this is cos x minus x for x less than or equal to 0. Again, it is cos x and plus x for x greater than 0. Isn't it? All right. Okay. Anyway, this is continuous function. So f dash of x is equal to f dash of x is equal to, I would like to write that minus sin x minus 1. This is for x less than 0. As I have taught in the class 1, do not include the endpoints. And this is minus sin x plus 1. Isn't it? For x greater than 0. Here clearly you observe that, LF dash of 0 is equal to minus 1. RF dash of 0 is equal to 1. So here both are not equal. F is not differentiable at 0. F is not differentiable at x equal to 0. So here the sum of differentiable and non-differentiable function is not differentiable at 0. You see here is another example that this is not differentiable at 1. Not differentiable at 1. at x equal to 1. And this is not differentiable at x equal to 0. All right. So this function is non-differentiable. This function is not differentiable. So here this is differentiable at, this is not differentiable at x equal to 0. Wait. What I would like to tell you is that this is not differentiable at 1, but this is differentiable at 1. But the difference, this entire difference, not differentiable at x equal to 1. Not differentiable at x equal to 1. Now, I would like to give an example that if sum or product or difference is differentiable, then individual functions are may or may not be differentiable, may or may not be. Here is an example, sin mod x minus mod x. I have done just now the way we have done that cos mod x plus mod x. The same way we can split the function. We can split the function that this is minus sin x, okay, and minus x for x less than or equal to 0. All right. I would like to take this is plus, okay, plus. And this is sin x minus x plus x, okay, plus x for x greater than 0. For x greater than 0. All right. Okay, let me think once whether I have to take here that minus. I'll see once. I'll see once. Well, I will adjust this example that I'll take mod x minus sin mod x. Just in order to explain that difference is a differentiable function, but individual functions. Okay. So accordingly, all right, for x negative, this is minus x and this becomes plus sin x. All right. For x positive, this is x minus sin x. Anyway, this is continuous function. So now what is f dash of x? F dash of x is equal to, you will get that minus 1 plus cos x for x less than or equal to 0, 1 minus cos x for x greater than 0. Okay. Here you do not include that equality. Now you clearly observe that what is left hand derivative, right hand derivative at 0, isn't it? Right. So here you see that f dash of 0 minus is equal to 0. F dash of 0 plus is also 0. Wow, nice. So here we got that the difference of these two functions is differentiable. Implies f is differentiable at 0. But neither mod x nor sin mod x is differentiable at 0. Good. Now in the similar manner, this is I have given for difference. We can create even for sum also. But here I am going to explain for product. Well, here you see that h of x is equal to, you take that f of x into g of x. All right. So this you can write that x into sin x square into sin 1 by x. Okay. I have explained this concept in the part 1 video. Please you watch that video also. 0 for x equal to 0. Now I will do not explain once again this function. Here h is differentiable. H is differentiable at x equal to 0. Right? But, but, but g is not differentiable at 0. G is not differentiable at x equal to 0. All right. Sorry. Okay. So if you want to me explain that what is h dash of 0, I can write in just one step. It won't take more than a minute. Limit x tends to 0, right? What is h of x? X square into sine 1 by x. And what is h of 0? 0. So therefore, by x, this is equal to limit x tends to 0, that x into sine 1 by x. So either you can apply that squeeze play theorem, or this is 0 into some finite quantity, oscillating function, isn't it? This is equal to 0. Hence that a function is differentiable function. Well, I'll move to that minimum and maximum of two or more functions. It is very difficult to explain limits, continuity, differentiability, each and every topic of calculus. But once you understand, if you do the very good practice of previous JEE Main and previous JEE Advanced, you will excel like anything. Here, differentiability of maximum and minimum of two or more functions. What is this maximum of two or more functions? It's not the matter of finding maximum of a function, not maximum of a function, right? It is maximum of two functions. So which function is more than the other function? This we would like to find out. Suppose here g of x and h of x are two functions, isn't it? Right. So you will write that g of x maximum if you know that h of x is lesser than g of x. Then definitely g of x is more than h of x. So maximum is g of x. And you will write h of x if h of x is greater than or equal to g of x. So maximum of 2 comma 3 equal to 3, since 3 is greater than 2. There is an alternative way of expressing this maximum of g of x and h of x. Sometimes in the examination, you will find this kind of expression. So sometimes it is very difficult to notice whenever this kind of expression comes that it is equal to maximum of g of x and h of x. What is this? Modulus of g of x plus h of x by 2 sum plus modulus of difference. Here without modulus, here modulus is there. You can verify it. If g is greater than or equal to h, then you can write g minus h by 2. H by 2, h by 2 will be cancelled. Then you will get g of x. So in the similar manner, we can define that minimum of two functions. Same way. If we write g of x minimum, if you know that g of x is lesser than h of x, isn't it? Well, good. And we write the minimum is h of x if h of x is less than or equal to g of x. And the difference between that minimum of two functions, maximum of two functions, for maximum here we have addition and here we have a subtraction, but the expressions are same. Here g of x plus h of x by 2 minus modulus of g of x minus h of x by 2. All right. Well, I'm going to explain that how do we find out maximum of two functions? How do we find out maximum of two functions and what is the procedure? Not only two, even 3, 4 functions. Well, here I have given a description that to draw the graph of two or more functions, right? To draw the graph of maximum or minimum of two or more functions. Sorry, 1 minute. To draw the graph of minimum or maximum of two or more functions. Well, okay. So draw all the graphs in a plane. Okay. If they have given two graphs, you draw the two graphs. Well, and find all points of intersections if they intersect. Whenever they intersect, you need to find out points of intersections. Right. All right. For maximum of given functions, we take top graph of the graphs in each interval. This is important point, right? In one interval, suppose there are three graphs. For maximum, you have to take the top graph, top one. Whereas for minimum, you have to take the lower graph. You have to take the lower graph. I will explain through this graph. I will explain through this example. Okay. Here you see. This is, I'll drag this graph a little down. Okay. So that we can read this matter and I can explain now. Now you see, roughly I have taken this, suppose for example, in fact, you need not to find out points of intersection, just you have to notice that. You have to notice that. So this is assume x1 and this is x2 and this is 0 and this is x3, isn't it? And this is x4, right? And this is x5. Suppose we would like to draw the maximum graph. So for maximum, you see that for less than x1, this is the maximum. Okay, there are two graphs. Among these two, this one is top of this graph. This is the top. And between x1, this is, wait 1 minute, and this is some x3, okay, and this is some x4, all right, this is some x5, x6, x7 I have given. Now you see that between x1 and x3, this is the maximum graph. This is the maximum. You just strike up. Between x3 and x5, this is the maximum graph. Between x5 and x7, this is the maximum graph. And for more than x7, this is the maximum graph. Whatever portion we have left, that is the minimum of the functions. Okay, I'll write again. This is x4, let us say x5, x6, x7. All right, you see, this function, I do not know what is this function, but we have a sharp edges at x2 and at origin and x6. So here this function is not differentiable at 7 points, at 7 points. Well, I can immediately create. Let us say this is a y equal to mod x graph. This is y equal to mod x graph. And the other one is a parabola. This is nothing but modulus of, I can say, x square. Let us say that minus 3x plus 2. Or I can say simply modulus of x square minus 1. Okay, modulus of x square minus 1. Even I can say this is the function. All right. Okay. So this is the procedure that you have to draw the both the graphs in a plane and then observe the points of intersections. In each interval, you see that top of the graph is the maximum and the lower of the graphs is the minimum of the functions. It is very simple, but the difficulty is noticing that shape of the graphs. So you must be good at drawing graphs. Here is one previous JE question that f of x equal to minimum of 1 x square x cube. If you are so good at this drawing a parabola and a cubic curve, then it is very simple. It is very simple. All right. You see that. This this is the graph of y equal to x cube graph. And this is the graph of y is equal to x cube. All right. Okay. And this is the graph of y is equal to x square parabola open upward sitting at origin. Sitting at origin. Nice. Okay. And this red line is that y equal to 1 line. This is y equal to 1 line. All right. We want that maximum graph or minimum graph, you see. See, we have that 3 graphs for less than this point of intersection. What is this point of intersection? This point of intersection is 1. You just substitute y equal to 1 in x square and x cube. All right. Right? Okay. Anyway, for less than 0, we do not care about this point. For less than 0, we have that this is the minimum graph. For x less than 0, this is the minimum graph. And till this point, this is the minimum graph. This is 1. All right. Okay, this is -1. Till 1, that x cube is a minimum of these 3. And the next one is directly this. Y equal to 1. All right. So therefore, what is f of x now? That f of x equal to, for x less than or equal to 1, we have x cube. But for x greater than 1, just it is 1. Now clearly f is continuous but not differentiable at 1. F is not differentiable at 1. Not differentiable at x equal to 1. Well, I'm going to explain one more question of JEE Advanced, even though it is JEE Advanced, but it's not at all difficult. It is very simple question. Here f of x equal to mod x plus 1 graph, and g of x equal to x square plus 1 another graph. One is modulus function, another one is a parabola. And they are defining maximum of f of x, g of x for x negative. And defining minimum of 2 functions for x greater than 0. Right? For different intervals, they have defined minimum and maximum. It's a matter of drawing the graphs of mod x plus 1 and x square plus 1. I'll draw those graphs. Well, here is the graph that this is y is equal to x square plus 1. Parabola moving upward. And this is y is equal to mod x plus 1. Mod x plus 1 graph moved by 1 unit along positive y-axis. Now we would like to find out for x less than or equal to 0, maximum of f of x and g of x. Maximum of f of x and g of x. And they will meet at -1. Okay, this is -1 and this is 1. For x less than or equal 0, we have to see that maximum graph. So maximum graph, nothing but you have to see the top graph. All right. And this over for x less than or equal 0, maximum. Whereas for x greater than 0, we have to see the minimum graph. We have to see that minimum graph. All right. This is the minimum graph. We have to take the below one. We have to take the below one. Right? Okay. So here this is the non-differentiable function. This is y is equal to 1 minus x. Okay. And this function is y is equal to x square plus 1. Easily you can verify it. Usually you can verify it that what is the derivative of this function? Minus 1. What is the derivative of this function? 2x. Substitute x equal to minus 1. They are unequal. They are unequal. Anyway, here we have a sharp edge. This is also. Right. So this is not differentiable. That h is not differentiable. H is not differentiable. Not differentiable at x is equal to minus 1, comma 0, comma 1. If you want express the function, I'll write here the function, complete function, right? For x less than or equal to minus 1, you will have 1 minus x graph. Between minus 1 and 0, between minus 1 and 0, you will have that. Okay. This is first one is not 1 minus x, that is 1 plus x square graph. Sorry, 1 plus x square. Maximum. Between minus 1 and 0, you look at here, this is the 1 minus x graph. Between 0 and 1, between 0 and 1, right? Between 0 and 1. You have to take that x square plus 1 graph. And the next 1 plus x graph for x greater than 1. Anyway, it is continuous function. So you just differentiate the function, then you will get non-differentiable points. Well, here is one more question on minimum and maximum of two functions. Right? Here minimum of x minus integral part of x, nothing but this is a fractional part of x. And here 1 plus integral part of x minus x. So we have to write that integral part of x value between two integers. Here I wrote that between 0 and 1, integral part of x is 0. Therefore, it becomes x. Between 1 and 2, integral part of x is 1. So it becomes x minus 1. Between 2 and 3, integral part of x is 2. So it becomes x minus 2. You can apply the same logic to express that 1 plus integral part of x minus x. Now we will draw the graphs of x minus integral part of x, that is known as a fractional part of x. So between 0 and 1, simply y equal to x line. Okay, y equal to x line. This is y equal to x line. Between 1 and 2 is y equal to x minus 1. They all have equal slopes, so therefore they are parallel. All right. Now you see that y equal to 1 plus integral part of x minus x equal to 1 minus x between 0 and 1. So what is x-intercept? X-intercept is 1 putting y equal to 0. And if you put x equal to 0, you will get y-intercept is also 1. And slope is minus 1. And slope is minus 1. So here we have the graphs will be like this. This one. We have drawn. All right. Now we would like to locate that what is the minimum of the functions, right? So this is one point of intersection, say it is alpha, the minimum is this one. Between alpha and 1, this is the minimum. And assume this is beta. Between 1 and beta, minimum of this function is this one. Between beta and 2, this is the minimum. And again, this is the minimum. And assume this is gamma, point of intersection. They are not asking to find out points of intersections, in fact, isn't it? All right. So now you see that they are asking that what is the P, where F is continuous, P is the cells, F is discontinuous. So there are no points of discontinuous. So therefore P equal to empty set, equal to empty set because the graph is continuous. Whereas Q is equal to at how many points this function is non-differentiable. You just have a close look at a V shape or inverted V shape. All right. So this is equal to alpha 1, beta 2, gamma, and 3. So F is not differentiable. Sorry, we would like to find out only between 0 and open 3. Remember, you read the question very carefully, open 3. So you have to exclude that 3. Mistakenly, I wrote. All right. So here F is not differentiable. F is not differentiable at 5 points. At 5 points. So what is the sum of number of elements in P and Q? That's equal to 5. Okay. In this way, it is taking too much time to explain the question. So I'll explain some more questions in separate video. Now I'm going to explain that solving of functional equations and some standard functional equations using differentiation or without differentiation. Well, so here is that f of xy is equal to f of x plus f of y. Means it is converting a product to sum. Then f of x equal to, you know that this is possible for k into ln x, k log x. Well, okay. Because ln ab equal to ln a plus ln b. Now f of x plus y is equal to f of x into f of y, nothing but converting sum to product. This is sum, right? This is product. All right. So this is nothing but f of x equal to an exponential function a power x. A power x. All right. And one more Cauchy's equation, f of x plus y is equal to f of x plus y is equal to f of x plus f of y. This is just very simple, f of x equal to kx. All right. And one more important is that f of xy is equal to f of x into f of y. The function satisfying this is f of x equal to x power n. And if f is a polynomial satisfying f of x plus f of y, okay, remember this is important, equal to f of x into f of 1 by x, then the function is 1 plus or minus x to the power of n. I'm just revising these standard functions. Now there are some certain kind of functions which can be transformed to standard functions, This is a very, very important. F of x plus y is equal to f of x plus f of y plus f of x into f of y. You just add on both sides 1. Add 1 on both sides. Then you will get that 1 plus f of x, isn't it? Plus, here you take that f of y common. Now into 1 plus f of x. So this I can write that 1 plus f of x into 1 plus f of y, isn't it? So if you assume that this is as a g of x, this is as a g of x, and this becomes g of y. So we got that g of x plus y is equal to g of x into g of y. Now what is the function satisfying this? In this way, rest of the equations, you must be able to solve them. Okay. I won't solve all the equations. So therefore, this implies what is g of x? G of x is equal to, just now I told that this is a power x. So therefore, what is f of x? F of x equal to a power x minus 1. The same exact question asked in advanced 2021 or 2020. Similarly, here you divide by e power xy, e to the power of x plus y. So f of x plus y by e power x plus y. Then we get f of y by this is e power y and f of x by this is e power x. Okay. Same as whatever I have done in the previous example, in the similar manner, you can assume this is g of x, so that you will get that g of x plus y is equal to, right? This is equal to g of x plus g of y. So therefore, this is nothing but g of x equal to some kx, some k into x. All right. So therefore, f of x equal to kx into e power x, kx into e power x. In the similar way, f of xy is equal to x into f of y plus y into f of x. You just divide by xy. You just divide by xy. Divide by xy. This is equal to f of y by y and plus f of x by x. Now again you take that this function as a g of x. This function as a g of x. Now what will you get? You will get that this implies g of xy is equal to, this is g of x into g of y. This is the logarithmic function, isn't it? So g of x equal to, we got some k into ln x. But g of x is f of x. Therefore, f of x equal to, this is kx into ln x. These are very important. These are high level functional equations. Okay. Converting into very simple. Here is a one question that which I can use the differentiability to solve this question. No, I hope this is not the question, but here this is that put x equal to y equal to 1. Put x equal to y equal to 1. Then you will get that f of 1 is equal to 2. Right? Now put y equal to 1 by x. Put y equal to 1 by x. We get that f of x plus f of 1 by x. Okay. Equal to, you will get that f of x into f of 1 by x. Rest all terms will be cancelled. Just now I told that this function is 1 plus or minus x power. That's it. Okay. All right. One functional equation based on the concave up and concave down. Concave up and concave down. This is the concave down function. This is known as a concave down function. And this is a concave up function. Concave up. This is a concave up function, right? So if you take a x comma f of x 1 point, b y comma f of y another point, I have taken 2 points. And I have taken midpoint of x comma 0, y comma 0. At this point, I have drawn a line perpendicular to x-axis so that it meets the secant line PQ at Q and the curve at R and the curve at R. Well, so here if you observe that PR is greater than or equal to PQ. Oh, I did wrong. Here, PR is greater than or equal to. Here, it's on reverse. See, the height PR is greater than or equal to PQ. Here, height PR is less than or equal to PQ. Well, so what is PR? PR is nothing but this is equal to the height at x plus y by 2. So I can write f of x plus y by 2. Oh, here I wrote already. This is PR. That is the height at x plus y by 2. And what is PQ? And what is PQ? PQ is equal to f of x plus f of y by 2 that you can obtain just by dropping the perpendiculars from A on QR and from Q on this line. You just finish. Okay. Anyway, this is the midpoint 1, 1. And these are the similar triangle. So apply the similar triangles concept. Apply similar triangles concept. Well, okay. You do that. In the separate video, I will explain that proof. Now you see that PR is greater than or equal to PQ. So therefore, I can write that PR is nothing but f of x plus y by 2 is greater than or equal to f of x plus f of y by 2. Per concave down. Per concave down. Similarly, I can write this is less than or equal to f of x plus f of y by 2. Okay. Per concave up. Per concave up. Nice. And equality occurs when this is a straight line. Equality occurs when this is a straight line. This is very, very important. That f of x plus y by 2 equal to f of x plus f of y whole by 2. If and only if that function is a straight line. That function is a straight line. Remember, this is very, very important. This is very, very important. F of x plus y by 2 is equal to f of x plus f of y whole by 2 if and only if that function is a straight line. Not only for this midpoint, you can take any dividing point. F of mx plus ny by m plus n is equal to m into f of x plus n into f of y by m plus n, where, of course, m comma n I am taking natural numbers. So this is possible only when that straight line. It is a straight line. X plus, that is ax plus b. Well, here is a question of previous J. You see that here is the question. Given that f of x plus y by 2 is equal to f of x plus f of y whole by 2. Immediately you take that f of x is equal to ax plus b. Do not hesitate. You have to catch it immediately. Then they have given that f of 0 is equal to 1. So therefore, this is equal to, this implies b equal to 1. And what is f dash of 0? F dash of 0 is a. So this is equal to, they have given minus 1. Hence, we got the function immediately that minus x plus 1. Whatever they ask, that you can find out that f of 2 is equal to minus 1.